Okay, I see that in this your understanding of x squared equals 1 and x cubed equals 1, but I don't see any work that explains the difference. So can you tell me what you know or what you understand about the difference between working with squared roots and cubed roots is?
With squared roots, wait, the difference between squared roots and cubed roots?
How did you come up with the same response?
All right.
Or what do you know about them?
So the square root of 1 is 1.
How do you know that?
It's because, well, let's say this. So 2 squared is 4, right?
Okay.
So therefore, the square root of 4 is 2.
So squared and squared roots are opposites.
Yeah.
Okay.
But here's the thing. 1 times 1 is 1.
Okay.
So therefore, 1 squared is 1, and therefore, the square root of 1 is 1.
I see. Okay.
But with cubed numbers, so the square root, so 2 squared is 4, right?
Mm-hmm.
But 2 cubed is 8.
And how does that work?
So 2 times 2 is 4, right?
Mm-hmm.
So multiply it by 2 again.
I see. 4 times 2 or 4 times 4?
4 times 2.
Okay.
So it's like you have this one number, which would be like the big number that the exponent is attached to. The exponent shows how many times you multiply the big number by the original big number.
I see. Okay. So, do you have more to share?
So yeah, so 2 times 4 is 2. So 2 times 2 is 4. Times 2 is 8. And again, 1 times 1 is 1. So 1 times 1 is 1. Times 1 is still 1.
I see.
And that's why x cubed is 1 solved is x1, but also x squared equals 1 solved is x equals 1. That's why they're both x equals 1.
I see. Whereas, explain to me how this one is different.
How this one is different? With negative 1? If you do a negative number cubed, you're gonna get a negative number. But here's the little thing. No matter whether or not the number is negative or positive, if you multiply it by itself, you're gonna get a positive number.
I see.
So, say you had like x. So let's say you had like 7. So 7 squared is 49, right? Well, here's the thing. If you take negative 7 and you multiply negative 7 by itself, so multiplying a negative by a negative, you're still gonna get 49, like positive 49. So a negative times a negative is still a positive.
Okay.
So yeah, if you do a negative squared, you're basically multiplying a negative by a negative, so you're gonna get a positive number. So there's no way you can get a negative number by taking a negative number and squaring it.
All right. I see several other problems here that deal with fractions. What was your process for dealing with these ones that are fractions?
Well, so let's take 27/64. And how, yeah. So basically what you do is you have to do the square root of the numerator and also the square root of the denominator. So So the square root of 27/64 would be 3/4.
Can you show me how that's represented mathematically? Because I don't see any
Well,
work
not
here.
the square root, the cube root.
Okay, if you were going to show me how you would draw a root, because all I see is a reduced fraction or a simplified
How you
fraction.
draw a root symbol?
Yeah, show me what that process was in your brain. Represent it mathematically for me.
All right. Should I flip the paper to draw it on the back?
That's fine.
Okay. So x cubed equals 27/64. Also, only now do I realize that the original problem had negative.
Oh, okay.
Hey, who cares? I'll just do the positive for the example.
Well, okay. And then you can explain to me what you would have done had it been negative.
Yeah. So basically, it's basically, like, so,
Do you need a break to gather your thoughts?
no, not really. Not really. I got this.
Okay.
So, basically, if no matter what you do to x, all you have to do is revert that process, and all you have to do is revert that entire process, and then it's all good, basically.
All right. Represent this mathematically for me. Show me the math symbols that you would use.
So with x cubed, in order to revert it back to a straight up x, you just have to do the cube root of x cubed.
What does that look like?
It looks something like this.
I see. Okay. And then what would you do with the rest of it?
So
you can show that. You can leave that work.
Oh, okay. All right. Sorry.
That's good because that shows me mathematically on paper what happened in your brain.
All right.
And so there's a rule there that you seem to understand, that if you're doing that on one side, you're doing that on the other side of the equation, or the equal sign?
Yeah.
Okay, so show me what that looks like on the other side.
So this hold on. So this is the same as this.
Okay.
So the square root of 27/64 is equal to the square root of 27 over the square root of 64.
I see. And then what's the next step in your process?
And also I forgot to change square roots to cube roots. Whoops.
Oh. How did you change that from square roots to cube roots? What did you do?
All I had to do is draw that 3.
Oh, okay. Then what?
Then you just so basically what you have to do is, it's like, so the square root of 27 is 3, right?
Yeah.
Because 3 times 3 is 9. 9 times 3 is 27.
Okay. I'm going to let you finish this. I'm going to stop recording it and let you turn it into your teacher tomorrow, okay?